we have a beautification mass function log x base 2 plus log x base 3 is equals to 5. And we are required to solve for the value of x. We are required to solve for the value of x. So let's go and do justice to this. Solution. We have log x base 2 plus log x base 3 is equals to 5. So we are going to apply change of base here. We are going to apply change of base here. Let us consider this law. The law that says if you have log a base b, this can also be written as log a or over log b. Let's apply this first and see what the result will be. So this will give us log x or over log 2 plus log x or over log 3 is equals to 5. Now there is no problem here. You take the log of the log or over the log of the base plus log of the log of x or over log of the base 3 is equals to 5. You can see that with this now we can easily factor our log x out. So now have, if you factor log x out, you now have log x into 1 over log 2 plus 1 over log 3 is equals to 5. So you can actually get your value of x. Log x now be 5 divided by this value. But before we divide it, let's just simplify it further so it will look more honorable. So log x into, consider that the LCM of this can be log 2 log 3. So this into this give us log 3. I have log 3 plus log 2. Log 2 divide this. 2 will cancel to have log 3. Log 3 times 1 give us log 3. So log 3 into this expression and the denominator. Log 3 will cancel log 3. Have log 2. Log 2 times 1 give us log 2. Is equals to 5. So we know what this is by this law. If I apply log m plus log n, this will give us log mn. So if we do that, we now have log x into log 2 times 3, which is what? 2 times, or 3 times 2, 3 comes first, times 2, or over log 2 times log 3 is equals to 5. So we'll continue this way and see what the result will be. So log x will now be equals to 5 divided by log 6 divided by log 2 times log 3. So log x will now be equals to 5 into log 2 log 3 divided by log 6. So you can see that this is a natural log. Therefore, our x, I'm going to apply a law which says if you have log m base x equals to n, this implies m is equals to x to the power of n. So this is, the base here is e, but there is no base, e. So that is the natural log. So our x will now become exponential. Our x will now become exponential. Power of exponential 5 log 2 times log 3 divided by log 6. And this will give us x to be equals to, if you press this in the calculator, this will give us x to be equals to 8.37. And this is what I refer to as method 1. Method 1. Method 1. So please, happy learning. Let's go. Solution. This is our method 2 of solving this equation. We have solved it before with method 1. So we have log x base 2 plus log x base 3 is equals to 5. So we are going to change the base to 2 so that we have the same base. So we are going to change the base to 2. You know, the change of base, if you have log A base B, so you can change the base to B to be equals to log A base B divided by log B base B. And so we're going to do that so that our base will be the same thing. So we're going to use 2 as our base to change this base. So we now have log x base 2 divided by log 2 base 2. We are using base to respect 2 to take this, plus log x base 2 divided by log 3 base 2 is equals to 5. I know log 2 base 2 is 1. So this will give us automatically log x base 2 over 1 plus log x base 2 all over log 3 base 2 is equals to 5. So LCM here is log, or let us not consider this, let us multiply each term by what we have as denominator because this is over 1. So the LCM is log 3 base 2. So let us multiply each term by log 3 base 2. We are going to multiply each term by log 3 base 2. So let's go. Multiply each term by log 3 base 2. So if you use log 3 base 2 multiply, it becomes log 3 base 2 log x base 2 plus log 3 base 2 multiply here, it will cancel this. Now we have log x base 2 is equals to 5 log 3 base 2. So here you can see that we can easily factor out our log. We can easily factor out our log x base 2. So now I have log x base 2 into log 3 base 2 plus 1. Because this time this will give us this. This times 1 will give us this. Is equals to 5 log 3 base 2. So let us divide both sides by coefficient of log x base 2. So we are dividing by, we divide by log 3 base 2 plus 1. We also divide this side by log 3 base 2 plus 1. So this will cancel this. We now have log x base 2 is equals to 5 log 3 base 2 divided by log 3 base 2 plus 1. I'm going to do something to this one. You know the law of logarithm which says what? Although we are going to remove it, we are going to bring it back. Because what gives us this one here is log 2 base 2. So this here is base 2. We are going to change this to log 2 base 2. So this automatically becomes 5 log 3 base 2 divided by log 3 base 2 plus log 2 base 2, because log 2 base 2 is 1. So we place this. I know law of logarithm, the law which says if you have log m base a plus log n base a, this will give us log mn base a. So if you apply this law here, remember the right hand side, which is log x base 2. If you apply this law here, we now have log x base 2 to be equals to 5 log 3 base 2 divided by log 6 base 2. How do we get this? 3 times 2 give us 6. And this is equals to, this is equivalent to 5 log 3 base 6. How is this log 3 base 6? Because they have the same base. This is the law we applied here to change the base log to the numerator, the base and denominator. So we can bring this one back to give us this. Therefore, this shows that this implies log x base 2 to be equals to 5 log 3 base 6. And if that is the case, this implies that x is equals to 2 to the power of 5 log 3 base 6. And this is our final answer. This is our final answer, because if you have, see the law we applied here, the law says if we have log m base x will be equals to n, then our x will be, our m, will be equals to x raised to the power of n. X raised to the power of n, therefore our x will be 2 raised to the power of this, which is this. And this. So we have log 2 base x plus, we have log x base 2 plus log x base 3 is equal to 5. We are going to apply the law change of base. If you have log a base b, this can be also written as log a base b divided by log b base b. That's a at the numerator and b at the denominator. If we do that, so we are going to use 3 as the base in this case, because we have used 2 before. We used 2 in method 2. Go and look for method 2 where we use 2 as the base. Log x base 3 over log 2 base 3 plus log x base 3 over log 3 base 3 is equal to 5. And you know that log 3 base 3 is 1. So we have log x base 3 over log 2 base 3 plus log x base 3 over 1 is equal to 5. So at this stage we are going to multiply each term. Let us remove fraction by multiplying each term with log 2 base 3. Multiply each term by log 2 base 3. So if we do that, let's see what our result will be when we do that. If log 2 base 3 multiply here, it will cancel this. So we are left with log x base 3 plus log 2 base 3 times log x base 3 is equals to 5 times log 2 base 3. So you see what we did? We use log 2 base 3 to multiply here, give us this, multiply here, give us this, multiply here, give us this. So we continue from there. So if we continue from there, we now have log x base 3 plus log 2 base 3 multiplying log x base 3 is equals to 5 log 2 base 3. So in the left hand side, we can easily factor out our log x base 3. So log x base 3 is equals to, we factor it out, log x base 3 into 1, because this time this will give us this, plus log 2 base 3 is equals to 5 log 2 base 3. So this is the coefficient of log x base 3. So we divide by log 1 plus log 2 base 3. Divide this side also by 1 plus log 2 base 3. So this log 2 base 3 will cancel this. So we have log x base 3 is equals to 5 log 2 base 3 all over 1 plus log 2 base 3. You know this one, we're going to change this one to something better. So we now have 5 log 2 base 3 divided by log 3 base 3, because log 3 base 3 is 1, plus log 2 base 3. So this is equals to log x base 3. So if we do that, we have our log x base 3. Our log x base 3 will now be equals to 5 log 2 base 3 all over. Apply the multiplication law of logarithm here. The multiplication law, which says if you have log m base a plus log n base a equals to log mn base a. So that gives us log 6 base 3. And this one and this, they have the same base. So it's equivalent as 5 log 2 base 6. So if that is the case, that means our log 3, log s base 3 is equal to 5 log 2 base 6. So therefore, our x log x base 3 is now equal to 5 log 2 base 6, which implies x to be equal to 3 raised to the power of 5 log 2 base 6. And that is our final answer for method 3.